Thank you for coming back to part 2. I am limited on the time I can record for these videos, so we are now looking at synthetic division. And synthetic division is a simplified shortcut of sorts for long division. But the reason that you still need to know long division is because synthetic division can only be used when your divisor, remember that second term, has a degree, exponent of 1, and a coefficient of 1. So if you look back to the ones that we did on the front page, there's only 3 of them that could be used with synthetic division. So these are the detailed steps. I trust that you can read. I'm not going to read this at you, but if this is my dividend and this is my divisor, what you're going to do is set up an upside down house of sorts, and the coefficients for your dividend are going to go inside the house. And then the opposite of your constant for your divisor, so whatever number this is, like say 2, the opposite of positive 2 would be negative 2, etc. That is what's going to go outside. And then this process is easiest to see in action, but you're going to bring down your first coefficient, multiply it by the number outside, add that to b, multiply, add, and repeat until you get all the way through your house. And that final number is going to be your remainder. And the rest of these numbers are now the coefficients of your quotient in decreasing power order. So what that means is if your divisor had a power of 4, your quotient will have a power of 3. So you'll have x cubed, x squared, x, etc. So just like with our long division, if we are missing a power, we need to put a placeholder inside the house. But let's jump into this first example. Inside, I'm going to have 5, -6, 4, and -1. Those are my coefficients, and then the constant in my divisor is -3. The opposite of -3 is +3, so that's what's going to go outside. I'm going to bring down this first number. It's not going to change, and now I'm going to start my multiplying and adding rotation. So 5 times 3 is 15. -6 plus 15 is 9. 9 times 3 is 27. 4 plus 27 is 31. 31 times 3 is 93. -1 plus 93 is 92. So again, that last number is your remainder, and these first 3 are the coefficients for my quotient. So my dividend had a power of 3, so I'm going to start with 5x squared, and then 9x to the 1, and then 31x to the 0, which means there's no x. And then my remainder, we still write the same way, 92 over my divisor, x minus 3. And there is my answer. So much faster, much simpler. We just can't use it every time. So let's go on to another example. This one I am missing a power of x to the third, so I'm going to need to put a placeholder of 0 there. Then -5, 4, 12. This time my constant is +2. The opposite of that is -2. I'm going to bring down the 1. It's not going to change. And now I'm going to start my process, multiplying, adding, multiplying, adding, multiplying, adding, multiplying, adding, and this one has a remainder of 0, so no remainder, so I just need to look at my quotient. I started with a power of 4, so my result will have a power of 3, so x to the third minus 2x squared minus x plus 6. And now the very last part, we're going to use synthetic division to completely factor this polynomial. So I'm going to start by dividing this by x plus 1. So setting up my house, I'm not missing any terms this time. So there are my coefficients. I'm dividing by x plus 1, so -1 is what will go outside. So I have 1, -1, 1, -1, -6, +6, and 0. So my remainder is 0, which is what we were hoping for if we're going to factor, right? This needs to factor evenly. So what this means is if I were to factor out x plus 1, divide by x plus 1 from this original polynomial, what I would have left over is x squared plus x minus 6. Now if I look at that quotient, this is a quadratic trinomial which I could use my x method on to factor further. So -6 would go in the top, +1 would go in the bottom. My two magic numbers that multiply to -6 and add to 1 are 3 and -2. So that x plus 1 that we took out originally stays in the front, and now this can expand out into x plus 3 and x minus 2, and now we have completely factored that polynomial. All right, this concludes our notes on long and synthetic division. Again, synthetic division is super nice and handy, but if we looked back on the front side, of our long division, we could use it for these three, because it's just x to the 1 and it has a coefficient of 1. But this last one, this has a coefficient of 3 and a power of 2, so it could not be used. And we could have used it on that last one as well. So pay close attention to when you can and cannot use synthetic division, and when you can, I highly encourage you to use it.